Okay, just a quick review on how we got our resistance. If you remember, first question, branch D to E, we ask ourselves what happens at point D, and if you answer it splits or there's a fork in the road, it's parallel. So we use our MAD method with the two resistors that we have. So we have our 3 ohms multiplied by our 6 ohms, 3 ohms added to our 6 ohms, and divide those two answers. And what we wind up with is replacing that whole mess with a 2 ohm resistor. Next part was from branch C to F, so there are no forks in the road, so we just add the two resistors up, so the 2 ohms and the 1 ohm, and I'm going to cover that up, and we replace everything that was there with a 3 ohm resistor. Next question is branch C to F and B to F, but we have to look at point B, and we have a fork in the road, or it splits, so we have to use the MAD method since it's in parallel. So 6 ohms multiplied by 3 ohms, 6 ohms plus 3 ohms, divide our two answers out, and that's how we got 2 ohms for this part. So everything that used to be out here is only worth 2 ohms. Well, now we have a very, very simple circuit. It's in series, so a half ohm plus 2 ohms plus a half ohm. So we can replace everything in this circuit with a single half ohm resistor, or excuse me, single 3 ohm resistor, because that's what the entire resistance is. We have to use this value to start getting our currents. You should have your current in branches sheet, and I understand if it made absolutely no sense to you. So we're going to try and get it to make some sense. We have to assign for the first part, before we get to assign a variable to the branch with the highest resistance, we need to figure out these two values. Since this is a series circuit, to find electrical resistance, it is my voltage difference over my current. This is the only time that I use the electrical resistance formula to find current. So we rearrange current is voltage difference divided by resistance. Well, I have my voltage difference, I have my resistance, so 9 volts divided by 3 ohms is 3 amps. And if you remember the rule for a series circuit, the current going out has to equal the current coming back in. The current is constant throughout the whole circuit. So that's how we get those two. It's the only time we use our electrical resistance formula. And you just have to do a quick reformulation. I'm going to peel this back like so. And I'm actually going to move this just a little bit. We're going to disregard this 1 ohm resistor down here because we have the resistance out here altogether. In fact, why don't I do this? This is where A2 is. At point B, things split. Now this is where we use the sheet current in branches. I have to look at the amount of resistance in each branch. I have 6 ohms and I have 3 ohms. Direction number 1 says assign a variable to the branch with the highest resistance. I could care less what your variable is. I'm going to use I. I like the letter I, so that's what I'm going to use. So I have assigned my variable to the branch with the highest resistance. Second step, to determine the variable amount in the other branches, I take my highest resistance and divide it by the branch I'm working on. So now I want to know what variable this branch gets. So I take my 6 and divide it by my 3, and I get a total of 2. So this branch gets 2I. If you think about it, it makes some sense. Twice as much current will flow through here as opposed to here because it has half the resistance as this branch. So just let that sink in. Twice as much current flows through here because there's half the resistance. Once I have these two values, all I'm going to do is add them together, and this is actually step 3. So I take my 2I plus my I, and I have 3 amps of current coming into this, so I have to set that equal to 3 amps, because that's what I'm splitting apart. So I add these together. I have 3I is equal to 3 amps. Solve for I is equal to 1 amp. So every place I see I replace it with 1 amp. Since I is right here, this branch gets 1 amp of current. Since 2I is over here, I take 2 multiplied by my 1 amp, and this will be 2 amps. So I'm going to peel this back and put 2 amps right there, because that's how much I have. If we look at point D, the circuit splits. So I have to go to my sheet that's current in branches and do the whole process all over again. Step number 1, assign a variable to the branch with the highest resistance. I'm going to make my variable X. Second step, take the highest resistance branch, divide it by the branch I'm working on. So I take 6 divided by 3 and I get 2, so that's how I get 2X over here. This has half the resistance, so it will allow twice as much stuff to go through. Step number 3, I have 2 amps of current flowing into this. And I'm going to set that equal to my variables. So I have 2 amps is equal to 3x. So x is equal to 2/3 amp. So every place I see the letter X now, I put 2/3. So X is on this side, so this has to be 2/3 of an amp. I have 2X on this side, so I go 2 times whatever X is, which is 2/3, and that makes this 4/3 amp. And I would prefer you leave it as an improper fraction. If things split at point D, at point E, everything comes back together. So I have 4/3 plus 2/3, so this is 2 amps. I'm going to take and write all of my values in on my sheet. So I'm going to go through. A1 is 3 amps, A2, 1 amp, A3, 2 amps, A4 is 4/3 amp, A5 is 2/3 of an amp, A6 is 2 amps, and finally A7 is 3 amps. Once I have all that, we're on easy street. Now I got to determine what the voltage readings are at each point. We are going to use our electrical resistance formula for this. So we rearrange to get voltage difference is electrical resistance multiplied by current. I know the resistance. I just need to know how much current is flowing into this, and there's 3 amps here. So half of 3 is 1.5 volts. If I go down to V2, I know my resistance. All I have to do is multiply it by how much current is flowing through here, and there it is. So multiply that by 1 amp. So this would read 6 volts. Moving over to V3, I know my resistance. All I have to do is multiply that by 4/3 of an amp, and I'll actually get 4 volts. I know my resistance on this side. I multiply it by my 2/3 amp, and I'll also get 4 volts. I know my resistance here. I multiply it by the current flowing through here, which is 2 amps. It's right there. So I will get 2 volts. I know my resistance here, so I need to know how much current is flowing through here, and there it is, 3 amps, so 1.5 volts. From your packet that you completed, each path should get the same voltage, and in this case it should be 9 volts. If we look, there are 3 paths for the energy to flow. This first path, the second path, and the third path. We're going to take and keep a running total. I have 1.5 volts plus 6 volts is 7.5 volts. If I add another 1.5 volts to it, I get 9 volts. If I go the second path, 1.5 volts plus 4 volts is 5.5 volts. Keep working, add 2 to that, and I get 7.5 volts. Keep going, I run into 1.5 volts. 7.5 volts plus 1.5 volts is 9 volts. Work out to the third path, 1.5 volts. I run across this one, 4 volts. Keep coming, run across 2 volts. If I add those 3 together, I get 7.5 volts. Finally, run into this one again. 7.5 plus 1.5 is 9 volts. Each path gets the same voltage, which is what should happen in this circuit. You may need to see parts of this again. It's okay. You can ask your sub to back up and show you different pieces of this, or watch the whole thing again. But that's how you find your current and how you find your voltage. It is vital that you have your current to find your voltages. You must do things in order. That is vital. So, you have the other circuit that I had given you last Thursday. You may work on that and complete your current and your voltage. And then I also have a couple other circuits for you to practice with. They may look slightly different, but the process is the same. Enjoy.